Hello everyone. I'm back again to keep plowing through this Bach tutorial number 9. This video is on section F, which is the second last section of the tutorial. And we saw in section E that things got quite crazy, and we continue the complexity with section F. So I don't think it makes sense to go through every single detail just because it will just take forever. So I'm going to sort of fly through things and show you what's going on. And I won't go into all of the details probably just for the sake of time. I'll set this to make fewer measures of music for now instead of 56 measures. But what's the difference here? As you can see this time, they're saying they're going to add some velocity handling so that some notes are louder than others. They're going to sometimes have 2 notes at a time. They're going to have some measures that get transposed. And they're going to add or subtract a 16th note here or there to put the pattern out of sync. So some cute stuff. As we saw earlier, we have our rest probabilities. We talked about this in the last tutorial. I'll just hit this at random a little bit to create some values here. We have the number of measures we want to generate, the probability that something will be transposed, which is between 0 and 1. Crescendo exponent, so it also does a global crescendo, that's set to 0.5. Dephrasing parameter, which is the adding or subtracting of 16th notes. And then possible intervals for the chords to create. And there's some defaults in there already, which might be more interesting than all these zeros, so I won't hit that for now. Let's just dump it and see what we get. Here's the default from the settings that we have right now. So nice harmonies here and there. The rests are kind of irregular. Interesting. Let's, for fun, before we look at the details, up the transposition possibility to be much, much higher. I'll do 50%. And the dephrasing, that is adding or subtracting from the pattern, I'll up that a lot too, so that it's very likely to add or subtract a 16th note from the phrase. Okay, so we've changed those parameters. Everything else is the same. I'll dump it again. All right, let's see what we have this time. Okay, so much less rhythmically active because notes either get changed from a 16th note into a 8th note, or they're going to basically a duration of 0, which is turning them into a rest. So we have a lot more rests now. So maybe, let's see, well, I'll let you play around with all the different possible combinations you can get out of that. Just for the sake of time, I think we should probably dive into the meat of this thing. So all of this is the same as it was in the last 2 patches. Inside of generate score, it looks initially the same, but we see extra stuff over here at the side, which we will get to. And some extra boxes are sort of in the midst of this crazy spaghetti of boxes that we saw last time. So let's just sort of assume that we have some idea of how this data is coming in and being routed, which I covered in the previous video. And now look at the places where they intervene to do stuff. So here we see where the velocities would normally just be shot out to be collected. They have a new subpatcher called handle velocities. Let's look in there. What are they doing with velocities? It's pretty simple. The existing velocity comes in and is essentially replaced by a random velocity. They default with a range of number between 2 to 4, and they take that and multiply it by 30. So you get a velocity of 60, 90, or 120. They set scalar, and that happens for every velocity that gets shot through here, and then they are all collected here and pushed out at the end when that entire voice is ready to be constructed. Okay, so that's where the velocities are being changed. And you could, of course, go in and play with this random. You could change this percentage. You could change the random interval here and see what you get. One thing I'll mention quickly is that unlike most max help files, if you save these, you actually change the original one. So I would say whenever you're playing with them, the best thing is to start by going out to the select all, copy, and then paste it into a new version of the patch. And when you do that, oh, there, look at there. There's all the secret score stuff we looked at last time. When you do that, you may want to save it and then open it again because and when you paste like this, it does not activate load bang. So make your copy, save it, close it, and then open the file again. It should behave just like the original, and you can edit to your heart's content without destroying the original help file. Okay, so back into the generate score area, we looked at the velocities. Here's where they add chords. So what are they doing? Occasionally, instead of having only one note at a time, they transpose it and add second notes. Let's see how that's done. So again, this might look kind of complicated, but let's take a quick look here. So the current pitch comes in. They send a clear to the collect to erase the collection of notes from the last instance of a note coming through. And then that pitch, which is technically a kind of linked list, gets sent into the bach.iter object. If it's already a chord, then it will iterate through the numerous members of that chord. And then for when the note comes in, meanwhile, we've over here created a chord interval set, which we saw out on the outer layer. And here's the default right here, where I'm clicking way over on the right now. So that list of intervals comes in, and the Zuccarelli list length object takes the length of that list, assuming it's greater than or equal to 1, i.e. there is some transposition being specified. It opens this gate and lets the intervals through. And then bach.reg is basically an object that just holds values. So those values come in and they sit there until they receive a bang, which happens when the note is sent through. So it bangs these intervals out of the register into a bach.random object. Bach.random picks one at random from its input list. So in this case, this list of intervals we have over here on the right side is that input list. So it's going to pick minus 100, 100, 400, or minus 400. And because of the duplicate hundreds and minus 100s, it's going to be weighted toward transpositions of 1/2 step up or down. And occasionally it will go a third up or down. Okay, so it picks one of those. And if this number coming in is 0, then it's going to send out 1. And then if it's not, it's going to send out this random transposition value that we just received. And that value goes into this trigger. This is the amount that we're going to add, so that's your 100 MIDI cents or 400 MIDI cents or negative 100 or negative 400 that's sitting there waiting to be added to the pitch. And then we send the number 2 out here. So this was setting this gate to output just the note and let just the note through here. That's what this 1 is doing. This is controlling the gate, setting it to output 1 where just the vanilla note goes through. But if we have transposition values, it sets the gate to output number 2, which flattens the note into just the text, not a list, and then shoots that through the Bach addition object. So we add the transposition amount, and the original value goes through 2. That goes into Bach.join, which is like the pack object or POC object. It puts them both together, wraps them together as a chord for the chord level of the score object, collects them all together, and then finally, this bang shoots the whole kit and caboodle out to the Bach.collect, and this happens for every single note of the score until they're all processed. So pretty huge. All right, so that was our add chords object or abstraction. Here, this is the result of the big transposition subpatcher over here, which we'll get to in a moment. But this is where the global time is added right there. And let's see here. Here we decide notes or rests, which we had done previously. We use a random value to decide whether or not to multiply value by -1, which turns it into a rest, or 1, which leaves it the same. Collect all those results and shoot them out, so that's not really new. Then down here is our dephrasing durations. And again, it looks kind of scary, but let me walk you through. The duration comes in, so it's by default. The first thing this trigger does is clear out the bach collect to empty it so we can build a new set of durations. It walks through the set of durations here one at a time, and first it flattens it so it's just the numbers and not a list. Then it's going to trigger it. It's going to clear new ones, and then it sends it through. In case there's more than one, it will iterate them, and for each one in the iteration, it bangs a random number. And if the random number is greater than this dephrasing percentage that we've sent in from the main interface, then it will send it out gate side 2 and possibly add or subtract a 16th note. If it's less than that dephrasing percentage, then it just opens gate number 1 and the original value gets shot through to the bach collect. If it does decide to change it, it puts it into this bach expression. See this $R1? That's for rational numbers, which means fractions. So it takes a fraction in, which is this left side original note value, and then if a random number, or if this original number is greater than 0, it adds a 16th note to it. Yeah, it adds a 16th and multiplies this. If it's less than 0, meaning it was already multiplied by minus 16, so basically it's going to add a 16th or minus 16th to that value. For each value, sends it into the collect. When they've all been collected, this bang here bangs everything out. We wrap it another level so it is properly formatted for this voice in the score, and then shoot it into this bach collect and pack everything together into collect and wrap that out when the whole input list has been processed. So I know it's kind of crazy, but also pretty amazing. And that's one of the reasons I'm walking through this complicated patch. It's just like this, but I certainly welcome you to hack away at it, and also just want you to sort of see the logic of this sort of virtuosic patching in action. So finally, this is the part that decides whether or not or how to process the transposition for an entire measure. And over here, we bring in the a bang from the original pitches coming through, and that clears this integer box, which is holding the previous transposition amount. First, it clears the ZL group. This is a list object that's part of Vanilla Max that allows you to collect things into lists. So it clears that. It then clears this integer box, sends a 0 there, so that we're not holding a value in there. And then it bangs an Uzi for whatever number of measures are in our entire score. For each measure in the score, it chooses a random number and decides whether to bang this existing transposition to be added for that note, or to choose randomly one from this list to be the transition value for the note. And then it groups all of these transposition amounts together and shoots them into the ZL.lookup. If the ZL.lookup has meanwhile gotten the value of -1 for a rest, then it does nothing. But if it has gotten, or I'm sorry, if it gets a -1 as the input from this Uzi, then it does nothing. It does nothing. Sorry, and then otherwise it will collect these and bang out the results, and those will be added to that we've already processed here, where we added the chords. Every single note in the list will get added, will get MIDI sense added to it there. That output goes into this Bach collect here, and then as happened last time, this trigger will bang through all of those. We already talked about the dephrasing durations, and finally the crescendo is going to take the MIDI velocities that are coming in and basically round a value here from the crescendo parameter. It's going to take that parameter, and as the longer we are into the piece, the crescendo amount will be. and it will inject through the score, collects all of that, wraps it up, and sends it out again. So again, this is a pretty quick walkthrough of this, but yet there's a lot going on here that could be opened up and played with. And again, that's kind of like my encouragement to you is to not feel overwhelmed if this cable salad is totally freaky, but to just use this as a kind of like the mad alchemist in the lab to say, I'm going to go in here and play around with this and change things around and see what happens and try to discern like what happens when I change this number or changes. Can I have fun with this? And as always, remember that you could also go back to the original fragment and customize this to be your own cool thing that makes it sound totally different, and then run it through the patch pretty much as is. That could also be a super interesting thing to try and play with. All right, so that was pretty long, but I hope you got something out of it, and thanks for watching. Okay, until soon, bye-bye.